when we first started building the product, one of the things that we realized was that most of our customers don't even know what's going on inside behind their firewall. So I'm going to start the demo out in the small. Once again, it's the idea that when I started talking about the demo, we were building that foundation of the telemetry going up to the PCE and sort of how that worked, which spawned our last bit of conversation. In this section, I'm going to show you Illumination in the small, and we're going to show you the graphs, and then we'll show you some of the things that you can do from this, and then we'll show you Illumination in the large, because I don't expect customers to be sitting in front of this like this, but we had to start somewhere. And so what we're looking at right now is a flattened set of workloads. And once again, we're not showing you network topologies here, we're showing you application topologies, right? Sort of to tie this back to something we touched on earlier, each one of these triplets down here basically identifies an application instance, okay? So this is my ordering dev US instance. Here's my ordering production US instance, okay? So basically, I'm effectively writing, we're separating those out. Now, when I started this, the way that the Illumination works is I actually am ignoring right now port 22 traffic, right? I'm ignoring a few different types of traffic, with the logic being I don't need to see them. One of the things, like in these distributed organizations that are pushing out policy authoring, they don't want the developers to actually have to know anything about all the core sort of what we call dial tone services. They really need to see their own application services, right? So we sort of declutter the map to show them what the application topology actually looks like. Now in Illumination, one of the things you're going to see are red lines and green lines. The red lines, I'll start with the green lines. The green lines indicate we detected traffic, and you actually have a policy that governs the traffic that we've detected, okay? The red lines indicate that we detected traffic and you have not yet written any policies that would govern that very specific type of traffic that we've detected, okay? Now, the other thing which is a quick note, this all maps very nicely into an RBAC model, right? So if I'm a developer for ordering, I can describe, Matt's a developer for the ordering in dev, and I can only write an author policy for the ordering dev instance, right? It doesn't mean that I can write policy for the production instance. However, the prod team can look at whatever policies I'm writing and choose to copy it and promote it afterward, right? So the beauty of the labeling maps very nicely into constraining how RBAC and control can actually happen. Because as PJ said, we see either the Ministry of Security or the distribution of security. And once again, we can't be pedantic about how customers are going to basically author a policy and transport themselves to wide open, to whitelisted going forward, okay? So I'm going to do a quick filter here. I'm going to filter only by my ordering application. So give me a moment. And you'll see just using that, we were able to sort of filter these two out. Oops. So you'll see these two separate instances here. Now, once again, sort of tying this back to what I showed you earlier, if I click on any one of these workloads, I still can get all that workload context that we saw earlier, okay? So we're once again marrying that information, that context and telemetry sent up to the PC, but here we're doing it in a much more application contextual basis, okay? So earlier I showed you on those separate tabs what we were showing. I can still get down there and actually show you all that information. But for the sake of this, let's just go back and look at that individual application instance, okay? So,
question. Is what you're showing us now, Illumination, is this included in the product?
Yes, this is absolutely included in the product.
No separate add-on license or anything like that?
It's all one flat price.
Great.
Okay? So we don't charge separately for that. Secure Connect is all the same price. It's keep going, use the whole thing. And that's actually a fantastic question. Because what we see with our customers is not one state does not fit all. Some customers go to an enforced state and on a set of applications, and some of them go to a illuminated state, right? So you don't have to be completely in one state. You can literally mix and match even down to the individual workload as you see fit, okay? Which is something I'll show you in a couple minutes, okay? So I showed you that. So once again, in Illumination, we're still going to show you that workload context being fed up to the policy compute engine. We're also going to show you what the traffic is, right? So once again, we're looking at contract provides information about what is talking to what, and we're going to use that in the graph formation So we have complete context that if I click on this red line right here, I can basically quickly get information. Oops, sorry about that. I can quickly get information about this line, right? So it's going to give me some information like the host name. This is from ordering load balancer 1 into web ordering.info, right? So that gives me some host name information. That's fine and dandy. But also, once again, it's that concept, if you don't go to the host, you can't really know what's going on. It's not just talking on TCP port 8080. Here's actually the process name that's forked up on port 88 at this point in time. So we're providing you some interesting information about that. So we know what exactly is going on. Now, we've given you sort of like that granular information, but that's probably not the way you want to think about this. Really, the way you want to think about this is in a higher level construct, okay? And the higher level construct that I'm going to map to this is that I want the web, which is providing the Tomcat service, to be able to use by the Nginx load balancer, okay? So I've labeled something Nginx load balancer, I've labeled something web, I want the web tier to be able to use by the Nginx load balancing tier. And if I want to write that policy, here's how I do it. We're going to give you the information right here to do that. So I want the Nginx load balancer to be able to use the web tier, and specifically to the Tomcat process. Earlier you asked about, do I need to know the ports protocols? We're going to give it to you, right? So we're going to help you go right along and author that policy because we have that information, and we're going to map that Tomcat process to port 8080 TCP on this very specific application. Now, a nice thing about this is I can activate Secure Connect right here if I chose to. Once again, the PC is going to take care of all the keys, and we're going to activate what's already inside of the host, right? So once again, there's no sort of proprietary encryption. We're going to take care of the pre-shared key generation, and then the local session key will be handled by the hosts. Some customers want certificate-based. That's fine if you have a good PKI. You know, obviously that's something we can afford, but most customers don't have a good PKI operating inside of every single host. So we take care of that for you. Now, I'm going to save, I'm not going to necessarily use that here because I don't need that inside my own data center. I'll save that, and what you'll notice here is that the red line is now turned to green, okay? We haven't pushed the policy yet. We're in sort of like, this is a draft mode of what actually is going to happen. I'm going to go ahead and provision this.
And it's an important point. We're like modeling what is going to happen based on the traffic we have. And we can sort of predict before, and Matt will show you, we can predict and show you the impact of a rule change that you're sort of making before you actually make that change, right? Because we can model this entire thing in the PCE and allow you to and give you that information.
Okay.
Two questions. First of all, what are the little stub lines that seem to come out of the little short lines? Are they loopback stuff or?
These ones right here?
Like coming out of the Nginx LB, there's
The lines that don't go
nodes.
anywhere.
It's the arrowhead.
Oh, they're the arrowhead.
Yes.
They're behind. Okay.
I'll give you a funny story about that, actually. So we used to have straight lines with arrows on it, right? And it was actually a bit confusing because like two lines like this, does that mean it's going in or out? So what we do is we follow a swirling pattern. So you can sort of start to learn directionality based on the actual arc of the line. And so what you'll see is things sort of arc from right to left, or left to right, sorry, looking at it from, and that gives you sort of the directionality of it. So for instance, I see that these ones are talking, you know, from the internet into this. That's the arcing, and it's talking out. You'll see sort of it follow that circular motion around. This web host right here seems to be talking out. It's following the same circular motion, but going up, okay? So you'll start to quickly glean some directionality out of this. A couple are little sort of like sightseeing bits of information. This is a representation of what we call an IP list. That's that idea that mapping IP address, subnet zones, VLSMs into our model. So you can just say, in this case, it's headquarters. That headquarters gets mapped down into that load balancer. I went out and provisioned the policy. Remember, I wrote that one policy which says that Nginx can use the web tier of that application. Now, it was a very simple descriptor. Here's actually what got plumbed down into that Nginx load balancer. Let's go to look at the workload details. And what you'll see now is a set of outbound rules going down into that host, and those represent the incoming interfaces on the 3 workloads that were labeled web, and they have 2 interfaces apiece. Therefore, we see 6 new outbound rules on it, right? If we were to do a sudo IP tables -L on those hosts, we would see a corresponding set of policies for it, okay? So once again, it's an important point, and PJ touched on it earlier, is we are computing both the inbound and outbound rules on every one of the hosts, okay? It's like OSPF, right? OSPF uses all of that information to form the graph, the IP forwarding graph. We're using all the information, that context and telemetry from the host, to form the relationship graph that dictates what is actually going to talk to what. I've actually just told Amazon to spin up a bunch new of the web tier of this particular application. And while Amazon's doing its magic, let me just sort of talk about how the Venn understands its characterization. And we do that via something we call a pairing profile. And the pairing profiles are important because they literally allow us to basically install the Venn as part of automation. And as part of automation, it's going to basically identify, this is, in this case, the web tier of the ordering application and the development environment. What happens is the Venn gets installed. It presents a key to the policy compute engine. The key gets thrown away. We install 2 tokens into the host. One's a long-lived token, which allows the PCE to identify it uniquely. One is a short-lived token, which allows us to detect clones. So if someone snapshots a VM, walks away, installs a bunch of malware, that you'll actually know about it. And so once again, it's this idea, if you don't go to the host, you can't necessarily know that something bad is happening. So let's see if Amazon has done its magic yet. I will, let's reload it. Sometimes it takes, yeah, so Amazon is doing it. So what's going to happen here is these workloads are coming in. We haven't seen any traffic for them, so we're going to generate some traffic while this is happening. But what's happened in the meantime, if I go back to that Nginx load balancer, if these workloads have checked in yet, yes, they have. But you'll notice before we only had 6 outbound rules on that load balancer. Now we've updated the graph. And not every single workload inside of that ordering application, only the workloads that have been impacted by the change. So once again, we're not recomputing Dijkstra for the entire forwarding. We're only computing the diff of what was actually impacted by any incremental graph change. And so you don't have to reconfigure VLAN or a group, a security group, as it were. We're just the impacted workloads as things change, as things spin up, and as things spin down.
And
okay?
this is a key point, right? Nobody changed the policy, right? He just orchestrated in like 10 new Amazon workloads. They sort of got, because of their labels, they sort of joined the model. And we computed the necessary instructions to sort of keep that that policy invariant continues to be true, even though there was change in the environment.
So in reality, as the environment changes, you're always updating the policies dynamically, right? That's the adaptive part you mentioned.
Yeah, we're updating the instructions necessary to implement the policy. You
Right.
don't like.
Sorry, yes,
Yes.
that's a good clarification. Is there any impact when a policy push happens or a policy change happens? Is there any packet loss? If you enable IPsec on that link, for example, is it going to blip for a bit? I'm putting my change control hat on for a second. I'm just curious if there's any interruption in traffic or if it's all pretty seamless and nothing gets.
I mean, it's all seamless. I mean, we can do. I mean, we basically. I mean, again, leveraging what's in the Linux kernel, like be able to sort of swap new sets in atomically is something the kernel sort of supports. You know, without any impact. Obviously, if during that change you no longer have, like, let's say we're making a policy change and you no longer have access, immediately those things are going to be shut down.
Sure.
As soon as it does occur.
Okay, thank you.
So a question was asked earlier about what happens when something breaks policy. I want to sort of quickly state, you don't have to be in the same policy state. So as you look around here, you see these with solid blue lines. Those are in enforcement mode, right? Even though we're in enforcement mode, we're still going to show you what's trying to talk to it and visually represent it. Some of these are in this gray mode. They're in just illumination mode. Now, what's interesting about illumination is we basically can allow you to set different versions of illumination. We have illumination building state. In illumination building state, we'll help you write policy. but we're not going to alert you if something breaks policy, right? Because the amount of noise you would generate while you're building policy would drive your ops teams up a wall and probably jump off the building. So instead, we just allow you to sort of write policy without having to go to any form of notification. When you feel like you've got there, you can move to what we call a test state. In a test state, we'll write every one of the rules, but the last rule is permit any log. And then if something breaks it and hits that policy, we'll send an alert, right? So if you're using ArcSight, we're going to send an alert to ArcSight. If you're using Splunk, we'll send an alert to Splunk, QRadar, whatever it is. We don't expect people to be sitting in front of this all day long, having chewing gum, right? So that when you're in this testing state, we're going to write all the rules, and then you will, if something goes wrong, you'll get a notification on it. And then when you feel ready about it, you can go to enforce state. We have customers. I had a customer that ran in test mode for 365 days, only because they were worried about that one thing that happens one time a year. And once again, before they were blind, the test state that they were in was 1,000,000 times better than where they were before, where they were completely wide open, right? So you don't have to go all in for all applications. You can go, I only want my databases to be in a test state, but everything else could be enforced. It really depends on how you want to actually operate the business. However, when things go wrong, right, if you get that alert and something goes wrong, you want to be able to get information about what happened and how you can make changes to it. So I actually had one of the workloads kick off a recon. It's going to go out and break policy. Now, traditionally, if it was behind your firewall, you probably wouldn't know that had actually happened. With Illumio, we're going to give you the context and telemetry to know what's happening. In this case, this workload, I did not have a policy that allowed this particular workload to talk to the dev or the HR application, but now you sort of see this. The nice thing about this is I did it in rapid fire, but it could be low and slow, right? It could just be that one time where it tries to connect and breaks a policy, whether that's across workload to workload, application to application, or even a port level policy, you still get that level of visibility. We're going to give you information about that. Now the question is, what do you do now? So you can choose to have a containment policy where you quarantine that. Could be automatically. I'm a little bit more conservative about that because I'd want to do that manually. So I actually made this quarantine over here. My quarantine policy is the only way that you can access the host is via port 22. That's a policy that I made. You could say it's port 21 if you're a telnet org, right? So if you're in Mordor and you want a telnet in. So we basically allow you to create whatever policy you want to create. I'm going to drag this one workload over to the quarantine zone. And by doing that, we're just going to, all we've done is simply relabeled the application to quarantine. And I made a default quarantine policy that says the only way in is via port 22. That very simple motion allowed me to change the rules on this. And the rules that it basically created is the only way in is port 22. What I didn't show you there is that we also, all the other workloads around it that were impacted, the diff, we also shunned that host. So none of them are allowed to talk outbound to that host at that point in time. Remember, the beauty of this is you're controlling both sides of all the connections. So if one goes haywire, you're not fully exposed. If one host inside of a VLAN, inside of that database VLAN gets compromised, all of the databases are compromised in infrastructure. With us, your exposure is actually down to the individual workload. I'd like to finish my set. Any questions before I keep going? Okay. I'd like to finish with an example of one of our customers. One of our customers had about 80,000+ workloads, and they were in, I don't know, a bunch of data centers. I forget the exact number.
37?
More than that. It's like in the 70s, 80s data centers. And because sometimes it was one workload in a remote location, that's, quote, a data center. And one of our big learnings that came out of this was that this concept of application sprawl, right? And so in our world, application sprawl is, hey, I've got a nice backbone, and I want redundancy. So redundancy says I will put my web tier in these 3 data centers and my app tier in these 5 data centers. My database is over here because you know what? I've got a lot of backbone capacity. Now, how are you going to write those segments, these layer 2 segments that span geographic locations? Questions?
On what you were showing us before, where you were shunning.
Yes.
So that's if you can see a connection because the server spun up inside here. What if it's a server that's not inside? Like just some random server is spun up. Can you see those you can't see one side of that connection.
As long as one side has a vent on it, right? So let's say there was a client, right, that, again, we don't have a vent on this client, and was sort of talking to a whole bunch of data center workloads, we would see a bunch of arrows into those, right? Because it's those 2 points of enforcement. So as long as we have one point of enforcement, we report the telemetry. And even each of those arrows are actually reported from 2 different places, right? And so yes, we just have to see one side.
Okay.
So this is an example where customer gives us metadata. They give us, we didn't necessarily install the workloads in this case to get there. And what happened was they wanted us to sort of work along. And by the way, when we first started on this, Illumination did not scale like this, right? We looked like a lot of the other products in the market where there's like one little app view and it looks really cute. But what we learned was that's not really the way the world works, right? So we had to figure out how to make Illumination scale. And we learned a lot about customer environments that we didn't really know about before. So in this case, they anonymized their locations. We actually ask all customers where we give them their data. They anonymize their locations. They anonymize their individual app names, which is going to go to a question that you asked earlier. I can go in and I can find a individual group. In this case, a group is actually one individual application instance. Now what's going to happen here is the PC is going to, if I clicked on it correctly, is going to go in and it's going to find the workloads labeled, that application name in that environment, and in doing so, it will actually bring up the workloads and what the connectivity graph looks like for those individual workloads. Our big learning in this exercise was we had made some really inaccurate assessments because the customers we were talking to earlier on versus the customers that we were talking to later on were fundamentally different. The earlier on ones seemed to be all inside of Amazon or all inside of one single location. And as we started talking to larger and larger organizations, what we learned was that they weren't just in one location. They were actually in multiple different locations. And the web tier, as I said, they had application sprawl. I wonder if I'm still having network connectivity issues. Sorry about this. There we go. Find one of the applications here. So hopefully my network connectivity, I don't even know what I'm clicking on right here. So it could be sprawled out. Oh, this is a simple application, it looks like. So this one is not even that difficult. I'm going to find you something big and bad.
Demo risk there, Matt.
Yeah, demo risk.
Policy sprawl, demo risk, remember?
Yeah. So let's see how this one looks. So the way, because I didn't really try to map out what this would look like. So we'll see, what we should see here is that the workloads in this particular application, you'll see web, it could be app, it could be database. They didn't have all their metadata in terms of the individual roles when we started down this path with them. What they actually had was just locations and sort of the environments. A lot of the environments were not all that accurate. And you can see quickly here that they actually had massive amount of application sprawl. So this is actually not that difficult, not that diverse of an application, but you can see that they're actually talking across multiple data centers. And so in order to segment the individual workloads and this, from the rest of the applications, it was basically going to be impossible. In this particular customer, we also were able to provide a bunch of other information. We found in the 80,000 workloads, there were 1,600s when we did the initial snapshot of what was going on, dev to prod violations that were outside of the scope of what they actually thought was going on. Of those, there were about 70 plus instances where dev, in this moment, were on port 22 into prod, or on RDPing from dev to prod, right? Because they had Windows inside of there. And then we also found instances where dev were talking to prod on like port 5432 MySQL, Postgres, or 3306. So one of the things that it does, it allows the customers to sort of see not just what's going on, but the sprawl of what's going on and what is happening inside of their data centers where they had very little east-west segmentation.